Hello everyone. Today I'm going to solve the third problem, maximum subarray. So let's check it. So here we can see given an integer array nums, find the subarray with the largest sum and returns its sum. So here input the nums are -2 1 -3 4 -1 2 1 -5 and 4, and the output is 6. Since the subarray -4 -1 2 1 has the largest sum, so how can we do it? We can apply here the Kadane's algorithm. So let's check how we can solve it with the Kadane's algorithm. So let's check. Let's have a algorithm. Let's have a example. So first, what we will do, we will. What is the num1? So this is, suppose this is num. And this is 0 number index, this is 1, and so on. So we keep the first. So like how do we solve it generally? Let's check it in that way. So first we can solve it like 1 plus 2 is equal to 3, then -6, can it be taken? Then it will become -3, then -3 plus 2, so it would be -1. So it cannot be the maximum subarray. So how we gonna do? We can take it like 1 and 2. This can be a subarray, but we cannot take this. Then we check this part. 6 and 2, -4, then -1. No. 4 plus 2 6 -5. So I guess this part could be the maximum subarray. 6 5, and if you take this -6 plus 2 -4, no, that is not possible. Or this whole part, -6 -2 -4 0 -1, no. So this 2 -1 -4 is the maximum subarray. So first of all, like I said, 1 2 3 -4 5 -6, the first 0 number index, we store it in the max. Okay, let's give it a name A, and then we select the current sum. This is the max. We've taken a variable, then the current sum, we can take it as, we can also take it the first index. Then what we're gonna do, we're gonna run a for loop. Simply we'll run a for loop. We will run a for loop, and then we will check from 1 to its length of the num, and then we can store the variable where like at each index we decide is first we have already told you they start a new subarray num I, then extend the existing subarray current sum plus nums of I. So let's do the code, and then I have already told you the simulation, so let's do the code. So let's take a function uh, max sub, then we'll take nums as oh no, we're not gonna take this approach. We take max sum is equal to max sum is equal to nums 0. So the current sum, we have to make current sum here we go. Now what we're gonna do, we're gonna make a for loop I where it goes to 1 from 1 to the length, it will run like 1 from 1 to the length of the num. Okay, then the current sum is equal to max nums I comma the current sum plus nums I. So the suggested code that shows it is like either expand the current subarray or start a fresh start. So right now we can dry run this code and we check it how it is working. No. Okay, let's save the code and run this. Python six. How is it 6? Like minus 2 1 minus 1 minus 3, no, that part 2 and 3 7 plus 2, no. Let's dry run this code. Why don't we just dry run this code? So let's check the sum. It is in the max minus 2, and then the current sum is also 2 minus 2. So first I is equal to 1, and then what will be the current sum? Current sum is the nums I. So I'm sending the nums, these parts, nums I is equal to 1, then this part, so this 1 comma the current sum plus num1. So the current sum is minus 2 plus 1 is equal to minus 1. Which one is greater? This one. So the current sum will be updated to 1, and the max sum would be what is the max sum? Minus 2. And what is the current sum? 1. So minus 2 and 1 is greater, so the max sum would be 1. So in the fresh case, so we make a table. Why don't we just make a table? Updated current sum, max sum. We will return the max sum. So from there we got the updated current sum is equal to 1 and the max sum is equal to sum is equal to 1 and the current sum is equal to 1. So the current sum is equal to 1, the max sum is equal to 1. When iteration is 1, when iteration is 2, then 0 1 2 minus 3, the current sum should be minus 3 comma current sum plus num I. So num I is minus 3, the current sum is 1, so that would be minus 2 and minus 3. Which one is max? Minus 2. So the current sum is minus 2, and the max sum is 1 because minus 2 is less than 1, and then I is equal to 3, the 4. Okay, the 4. So these 4 that we make, what is the current sum? So 4 comma current sum is equal to minus 2 and 4 comma minus 2 plus 4, so that would be 2. So 4 is maximum, so current sum is 4 and 4 is greater than 1, the max 4 is 4. The max is 4 since 4 is greater than 1. And then when I is equal to 4 minus 1, then minus 1 comma minus 1 plus 4, so 3. Then current form will be updated to 3 and this remains 4. And then when I is equal to 5, then 2, so 2 comma 3 plus 2, 5. So 5 would be the current sum and this would be the also max would be the sum, max would be also 5. And then 6 6 would be 2, and then 1. 1 plus 5 plus 1 is equal to 6. So 6 would be the current sum and the max sum is 6. And then when I is equal to 7, then minus 5. The minus 5, that all will be decreased. Okay, the all will be decreased. It will be minus 1 and plus 4 minus 3. So this is the maximum subarray total, the sum of the subarray. So 4 minus 1, 2, 1. This is the final subarray that outputs the maximum number. So again, I am telling you the Kadane's algorithm. So first we take an array 4, 5, minus 1. We set the 0 index max sum and the current state 0 index set max sum and the current sum at the 0 index. We put the number which is indexed in the 0 position. We assign it in the max sum and the current sum, and then take a loop and run the loop from 1 to the length of the num, and then we take current sum, and current sum is calculated with the max function of num I comma current sum plus num I, and the max sum is equal to max of max sum and current sum, and we will return the max sum. So we pass this array in the max sub and we get our result. So what would be the time complexity? So the time complexity, here we can see this is O of 1, O of 1. This is a O of n. So we can solve it in another way that would give us n log n, that is divide and rule conquer, which is more subtle to solve this problem. So if you check the divide and rule conquer, I am showing you how it is done. So I'm taking only 4 minus 1, 2, minus 3, 6, 7, and it seems this is the highest part. So let's take another 8. This is the highest part, so let's check it. So from dividing, minus 1, 2, this is divide and conquer algorithm, 6, 7, 8, and then we divide it into minus 1, 2, and there is minus 3. Six, 7, minus 8, and then minus 1, 2, minus 3, 6, 7, and 8. So we have divided. Now we have to calculate the LS, RS, CS. for every part we have to make this. So here the ls would be -1 because we have only one node. For this it would be 2 2 2 2. For this it would be -3 -3 -3, like ls rs. ls is the left side terms sum, and the right as rs means the sum of the right side, and the cs means sum of the, like, which is crossing over in the both side. And here the 6 6 6 7 7 7 8 8 8. Now it has two parts. This has two parts, left and right. So what is the maximum in the left side? -1. So for this ls will be -1, and for this rs will be 2, and if we go there, this 2 and 1, 2 and -1, so 2 plus -1 is equal to 1. So rs will be 1, sorry, cs will be 1, and there also the same, because -3 -3 -3. And let's check it for this part. So what we're gonna get, the highest part is for this is 2, and the highest part is this, for this is -2, and rs is, if we divide this here, -3, we will avoid it, so 2, so we will take 2. You cannot take minus value, so here if we go to, it will become -2. Maybe if we go there, we get 2. And for this part it is 6, and for this it will be 6, and for this it will be 7, and 6 plus 7 is 13, and this would be 8 8 8. So for this calculation, the highest part is 13, on right side is 8, and if we calculate both 6 plus 7 plus 8, then it would be 13 plus 8, 21. So from the right side highest is 2, from the left side highest is 21, and here we can see, if we want to take the highest part number, then it would be 21, because if we go there, then it have to deduct from 21, so it would become lesser. So the highest number is 21. So for this, the max, the value of the subarray, the value of the max subarray is 21. So we check it, we can calculate it, it is 21. So this is the process where we can solve it by divide and conquer process. So if we like to do the code, then you can practice it in your home. So for today I'm shutting it down. Thank you so much.